Algebra 2. Today we're going to look at how to solve quadratic equations using the quadratic formula. Recall from the last section that a quadratic equation is one that has a variable raised to the second power. The standard form of quadratic equation is ax to the second plus bx plus c equals 0. You want all your quadratic equations again to equal 0. Remember from the past that the first term that has x to the second is the quadratic term. The x to the first term is called linear, and if there's a number constant, it will be in this position in the equation. Sometimes quadratic equations cannot factor. You'll try and there won't be a GCF, or it won't be a DOS or trinomial, or any of the other methods we've learned in the past. And so we have to have a way to solve those types of equations, and that's where quadratic formula comes into play. This formula will work no matter what type of equation, as long as it's quadratic, whether it factors or not. So that's the nice thing about the formula. It always works. To find the x answer, to find the solution for x, you're going to follow the following formula. Negative b plus or minus square root of b to the second minus 4 times a times c, all divided by 2a. The a is the coefficient of the quadratic term, the b is the coefficient of the linear term, and the c, again, is just the constant plane number. The part that's underneath the radical, this part here, b squared minus 4ac, is called the discriminant, the number underneath the square root. After you simplify that piece, the b squared minus 4ac, whatever type of number you get, whether it be a positive number, a negative number, or maybe even 0, that particular number is key to telling you what type of answer and how many answers you should receive. If the discriminant is greater than 0, or if it's positive, in other words, then you would expect to get 2 real solutions. If the number underneath the radical after you simplify is less than 0 or is a negative number, then you would expect to get what's called 2 imaginary solutions. And we haven't talked about imaginary numbers in this class yet, so when we get there, I will give you more details. If that number is equal to 0, then you would expect only 1 real solution. So the b squared minus 4ac, which is called the discriminant, and is the number underneath the radical, that particular value is going to tell you how many answers to receive and what type they are, whether they're real or imaginary. When the discriminant is positive, what will happen in a graph is the parabola, because a quadratic equation will form a U-type graph, the quadratic equation will cross the x-axis 2 times. I'm going to say that again. When the quadratic equation, it forms a U-shaped graph every time. When that parabola or that U-shaped graph crosses the x-axis twice, then that's indicating that there are 2 real solutions. Okay, so that's when it's positive. When the discriminant, b squared minus 4 times a times c, is a negative number, which means it's less than 0, then the graph of the entire equation will turn out to be a parabola. But what will happen, because its discriminant is negative, is it will not cross the x-axis. So it'll look like something like this. This type of graph doesn't hit the x-axis, meaning there's no x-intercept, no solution, and that's why we call it imaginary. There's no real number solution, and you are used to real numbers, so that's what that indicates. And then the third scenario, again, is when the discriminant, the b squared minus 4ac, when that's equal to 0. If it's equal to 0, that indicates there's only one real solution. And what happens in the graph in this case would be the parabola would only go low enough to hit the x-axis in one location. Like we'll call it there. And so that's your three kind of ideas and graphs, so you can see in your head how the graph ties into the algebra work. One more time, when it is two real solutions, you would expect the graph to cross twice. When there's one solution, you would expect the graph to hit the x-axis once. And when there's no real solution, otherwise known as imaginary, you would expect the parabola to not intersect the x-axis at all. Example 1. Solve the following quadratic equation. We have 2x the second minus x is equal to 4. First thing you want to do is make sure you have all your parts. You've got the quadratic step, or quadratic term I should say, in front. You've got a linear term right here, and you also have a constant number. The problem with this question is the fact that it's not in standard form, so the first thing you would need to do, just like you did with the factoring method, is you would want to make sure that you transposed and set the entire equation equal to 0. So now it reads 2x the second minus x minus 4 is equal to 0. The next thing I need you to do in your practice set is, to the side, I want all of you to list your A, your B, and your C. Just very quickly on the side to every problem. The A is the coefficient of the quadratic term. In this case, it's 2. The B is the coefficient of the linear term. In this case, it is -1. And the C is the constant, and in this case, it's -4. The next thing I want to see from all of you on your practice set is that you write down the quadratic formula every single time. I'm asking you to do that for each problem just because I know the more you write something, the better chance you have of memorizing it a lot faster. So again, make sure in every single problem that you, one of the first things you do is you write down the formula. X equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. This is asking you to do the opposite of b. I'm going to go ahead and drop down my negative sign from the formula. My b, though, is -1. So the opposite of -1 becomes positive. I'm going to change that in a second. And the next piece of the formula is this double sign, positive, negative, then your square root. Then it says b squared. On this part right here, please make sure you always get yourself in the habit of using parentheses and writing it like that. The b, again, in this problem is -1. Then my minus sign. Then 4 times the a, which is 2, times the c, which is -4. All divided by 2 times the value of a, and in this problem, a is 2. after you get the formula written down and the correct numbers substituted in, the next thing you're going to do is look at the discriminant and start the process of trying to simplify. You're going to need to use PEMDAS in order to do so. So, next step, I've got the opposite of -1, which is a +1. We're going to look underneath the square root symbol. We have an exponent, a subtraction sign, and we've got multiplication going on. We always do the exponent first. So -1 times -1. That's why it's also important that you use parentheses here. Because remember, and I've made the comment in the past, when you're using a calculator, if you type in just -1 squared, as opposed to parentheses -1 squared, you will get two different answers. So please be super careful. Always use parentheses. -1 times itself is a +1. I'm going to drop my minus sign down. And now I'm going to focus on the multiplication. The part I'm circling, 4 times 2 is 8. 8 times -4 is -32. Okay, then we're going to divide all of that by 2 times 2, or 4. Now, notice that all I've done is the power and the multiplication. I also see, obviously, that I've got a double negative here that needs to be changed to a positive. In the next step, I'm going to show that. So it's going to be 1 plus or minus the square root of, and we're going to go ahead and add 1 plus 32 to get 33. And remember that it's all divided by 4. I'm then going to pause for a second. Notice that I, after a couple steps, have found the discriminant to be 33. The discriminant, again, is the number underneath the radical. The discriminant is 33. Because the discriminant is a positive number, that means, based on our notes, if the number is positive, you are expecting to get two real solutions. So I'm going to just make that comment to the side. Two real answers. Now, the rest of this is going to show you how to actually find those answers. What I want you to notice is this double sign here. One of the answers is 1 plus the square root of 33, all divided by 4. And please make sure that division bar goes all the way across. A second option for an answer is 1 minus the square root of 33, all divided by 4. And then often, it depends on the directions, but sometimes you can leave your answers like this in radical form. Other times it's best to use a calculator, so I'm going to do both in the notes so you know what to do. And now, taking your calculator, which should be handy, you're going to type in the square root of 33. See if it is a nice whole number. Unfortunately, this one is not. It's a decimal. So now we have to kind of decide how we want to round this. I'm just going to do the nearest hundredth, meaning two numbers after the decimal. You can do tenths, thousandths. Just follow the directions. If it's not specific and doesn't tell you, then you can do either. Okay, and then we're going, same thing. This is the same problem, so I would expect to get 5.74. And then to complete this, just use your calculator. Of course, you want to make sure that you're simplifying the numerator first. So 1 plus 5.74 is 6.74. And you're going to divide that by 4. Okay, so we'll do that now. And I'm seeing x is equal to 1.685 is what my calculator is showing. I'm just going to go ahead and write all of it. But that is one solution. And it's definitely a real number because it's a number that we are used to seeing. We've seen before. It's also a number that we can definitely plot on a number line. To continue, you're going to now find the other answer by doing 1 minus 5.74. And that answer is negative 7.74, negative 4.74 divided by 4. Okay, so there's my two real solutions. Again, just to make sure that you are understanding, one option is to leave your answer in radical form. So here's two answers, 1 plus or minus radical 33 over 4. Or you can continue and get two decimal answers, 1.685 and negative 1.185. Notice the difference, obviously, in those answers. Example 2. First, check to see if it's in standard form. Quadratic term, linear term, constant, set equal to 0. Next, you're going to list your A, B, and C. Then, I'm doing the same thing I'm asking you to do. I need you to write down your formula. Quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. I'm going to drop my negative down. The b is negative 3. Go ahead and change it to positive if you want. B squared, again, needs to go in parentheses, just like this, minus 4, parentheses, the a value is negative 2, the c value is 5 this time, and all divided by 2 times the value of a, and in this problem it's negative 2. Alright, and now it begins the process of simplifying. Opposite of negative 3 is 3. Drop your plus minus. Drop your radical. Now you're going to do this part. Negative 3 quantity squared. Negative 3 times itself is positive 9. Drop my minus sign down. Focus on these three numbers multiplied together. 4 times negative 2 is negative 8. Negative 8 times 5 is negative 40. Denominator, 2 times negative 2, negative 4. And then quick comment, because I've been using this as a minus sign. If you want to, some people prefer thinking of this as a negative. So negative 4 times negative 2 is positive 8, and 8 times positive 5 is positive 40. You can do it that way as well. That's fine. Because a negative is the same thing as a minus sign. Even though we say it, we read it differently, it really is the same thing. So we'll leave that part up to you, whether you want to drop it as a minus sign or you want to use it as a negative on the first number and then just multiply all three numbers together and record your answer here. Next, you're going to see 3 plus or minus square root of 49 So it's going to be 3 plus or minus the square root of 49 divided by negative 4. And then we're going to pause for a second. And we're going to focus on our discriminant. We got it down to a single number. So a little quick note to the side, discriminant is 49 right now. Because the discriminant is a positive, that means, according to my notes, there are 2 real solutions. So we would expect 2 real answers. Then you're going to do, if you need to use your calculator, the square root of 49. And this time, this turns out to be a nice whole number. And the answer to that's 7. We know 7 times 7 is 49. So we're going to go ahead and record the answer. Notice that the radical is gone because you've already simplified it. So now the problem reads x can be found by doing 3 plus 7 over negative 4 and 3 minus 7 divided by negative 4. And I would suggest you write it out twice like I'm showing in the notes right now, just so you don't make a silly error at the end. So I would write it like this. So now x is going to be equal to 10 over negative 4. And let's see, let's go ahead and simplify that or finish it. 10 divided by negative 4 is the same thing as negative 5 halves. So that's my first answer for this problem. And then for second problem, I have 3 minus 7. Well, that answer is negative 4. And negative 4 divided by itself is a positive 1. So please notice that these answers are different. I've had people in the past that thought if this one's negative 5 halves, they would expect this to be the opposite sign. That is not the case. So please be careful. Make sure that you're working it out like I'm showing you here, and that way you avoid a silly mistake. Negative 5 halves and positive 1 are the 2 solutions to question 2. Okay, one more for today. And we're going to notice that the equation's in standard form. The a is 1. The b is the coefficient of x. In this case, it's negative 16. And the c this time is 64. You're going to write your formula back down. X equals negative b plus or minus square root b squared minus 4 AC, and that's all divided by 2 times A. And here we go. X is equal to the negative version of B, which is negative 16. Underneath the radical, I need the B squared, so I'm going to use parentheses, negative 16 squared. Drop my minus and my 4. My A value is 1. My C value is 64. All divided by 2 times 1. Next step, we simplify. That, of course, is a positive 16. We're trying to find our discriminant right now. We're going to do power first. Negative 16 squared is going to be a positive 256. Again, think of this as a minus or a negative, either way. 4 times 1 is 4, and 4 times 64 is 256. Or a negative 4 times 1 is negative 4, and negative 4 times 64 is a negative 256. Same answer, just different way to say it. 2 times 1 is 2. Alright, notice the discriminant right now, what's going to happen. I've got 256 subtract 256 is going to leave me with a 0. And time to evaluate this, simplify. Before I do that though, a little quick note to the side, discriminant is 0. You go back in your notes, if the discriminant is 0, then expect one real solution. So this time, we would expect only one answer. Let's see how this is going to work, because I see plus minus here. Alright, next step, and hopefully you already know where this is going. You can see that. The square root of 0, what number times itself is 0? Well, that's just 0. Technically, this means that one of the answers is 16 plus 0 divided by 2. And the other one is x is equal to 16 minus 0 divided by 2. Well, when I add 0 to 16 or subtract 0 from 16, I'm still getting the same value on top, obviously. And so, according to the notes, it's saying I only get one answer, and that's because when you simplify this, you're getting the same answer twice. And that does happen when the discriminant is 0. So you don't necessarily, like I'm doing right now, you don't need to write it down twice. You can just write it once. There's my answer to that quadratic equation. And then one thing I do want to share with you on this one before I stop for today is notice that in this problem in particular, it is already in standard form. I had to make sure of that before I jumped right into the formula. But what I want you to notice about this problem is factoring would have worked here. That's because this is a trinomial, and remember from the past, when we're doing trinomials, we draw a T-chart with factors of the first number, factors of the last number, and you list as all the ones that you can think of. And there's tons of these. 2 times 32, then do 4 times 16, 8 times 8, so forth. Okay, so that list keeps going. You're going to list all of those. Then you're going to come over here. I'm trying to move ahead so I can show you why I'm doing this. And then the factors of x squared are just 1x and 1x. And then if I had listed all my factors here, I would have been able to pick the one that would add to 16, and that will be 8. Well, since the sign at the end's a plus, that means the signs in the middle, or the sign in the middle tells you what signs to write in your answer. I need a negative 16, meaning I need a negative 8 on the outside, a negative 8 on the inside to give me that. From the last section's notes, after you factored it, you then took each factor and you set it equal to 0 and you solved the equation. And you can see what's going to happen. When I transpose, I'm going to end up getting an 8, and that's exactly what I got down here using the formula. It's just, like I said, a different method, a different approach, solving the problem 2 different ways, but expecting the same result. So same answer, and in this case it is 8. When given the choice between the formula and factoring, I personally, when I know a problem factors, I like factoring because it's faster for me. The advantages to the formula is, of course, this works every single time, no matter what problem you're given, as long as it's quadratic, as long as there's a power of 2. Okay, so kind of keep that in mind. So again, today you've learned how to use the quadratic formula. You may have had this in the past in another class, and if so, that's even better. It's just drill and practice here. Make sure you memorize the formula, and again, you write it every single time for every single problem. Okay, so we'll give it a try, and let's see how we do.